Right, so we've moved into a process now where we're going to be working backwards from our normal distribution curve, where we're being given an area, a probability, and we're looking for the boundary value that creates that area. So if we look at A, I want the probability that Z is less than A equals 0.611. Now, because we're working with Z, I know that I'm working with the standard normal distribution, which has got a mean of 0 and a standard deviation of 1. So that area there is going to be over half. So it's going to be that sort of region, and that value of A is what I'm looking for. So this area has got to equal 0.7611. On the calculator, we're going to go back to our distributions, and now we're going to choose 3, the inverse normal. We're going to use it backwards. The area is 0.7611, and I'm already in the standard normal distribution, standard deviation 1, mean of 0, so I can leave that as it is. And that's telling me that A, that boundary there, is 0.71. Or 7098. So that's A. Part B. This time, it's a little bit more work we need to do. I want to know where A is, such that the region above it is 0.01. The problem here is that the calculator only measures less than values. So we won't get this off the calculator. What we'll get from the calculator is its symmetrical opposite. The calculator will tell us what that value there is less than, what probability less than gives us an area of 0.01. So I'll just show you how that looks on the calculator. So 0.01, everything else is as is negative 2.33. So that is that. So from the symmetry of it, that means that A equals 2.33. C, same thing again, it's a greater than. My curves are getting uglier and uglier. So I want the area which is greater than 0.0287. I'm not going to get that from the calculator. I'm going to end up with this value is less than. So on the calculator, I've got 0.0287, negative 1.9, which means A is the symmetrical opposite of that. So A is 1.9. And then part D, Z is less than, so this one is one we can read straight off the tables. So we're interested in the area being 0.0170. So 0.0170 minus 2.12. So once more, using the calculator has made this technique significantly less work than we would have had to have done if we were using published tables. The only thing you have to be careful about is that when you're using an area and you want to find an is greater than probability, you remember that it's symmetrical and the calculator will give you the is less than probability.